Hi, I'm Will. I'm one of the circus riggers at Stockholm University of the Arts in Sweden. In our circus school, we use equipment from many different places and different kinds of equipment. Now, they don't necessarily all follow the same standards. In this video, we'll have a look at how to understand what's marked on them and the difference between a braking load and a working load limit. Now, I've got two pieces of equipment here, and we're going to look at how to determine the strength of each of those bits of equipment, even though they are manufactured to completely different standards. Let's look at this. This is a lifting accessory. It's a shackle. Came from the lifting industry. It's designed to connect two pieces of equipment together. We could use it to connect an aerial rope to a round sling that goes over a beam. This is a carabiner. It's a piece of climbing equipment. Like the shackle, it's also a connector. For example, we could use these, or we often use these, at the end of a lunge to connect to a safety belt. Both these things have markings on them to tell you how strong they are. Let's start with the carabiner. The markings on this say MBS 27KN. So what does that mean? Well, MBS stands for minimum braking strength. So if you're loading it more than that, it will lightly brake. KN is kilonewtons. It's a unit of force. So let's keep it simple and just say that 27 kilonewtons is roughly equivalent to 2,700 kilograms. What this tells us is that if you load this more than 2,700 kilograms, it'll probably break. Now let's have a look at the shackle. The shackle has stamped on it WLL2T. The WLL, that means working load limit. 2T is 2 ton. Unlike the carabiner though, it doesn't tell us what the minimum braking strength is. What it tells us instead is the working load limit, the maximum weight that the manufacturer says you're allowed to place on it in an industrial lifting application. So how do we find out what the minimum braking strength of the shackle is so that we can compare it with the carabiner? Well, the manufacturer states in the documents that this has a factor of safety of 5 to 1. This means that that they have reduced the braking load 5 times to get to what they tell us is the working load limit, what you can use it for in industrial lifting. With a working load limit of 2 tons or 2,000 kilograms, when we factor in that factor of safety of 5, we get 2,000 kilograms times 5 is 10,000 kilograms. So now we know what the minimum braking strength is of the shackle and of the carabiner. What did we learn? Well, equipment can conform to different standards. When you're looking at rigging, it's worth knowing how to differentiate between them. Climbing equipment will normally have the braking strength written on it. Lifting equipment will normally have the working load limit with a certain factor of safety. Knowing what a factor of safety means can be really useful later when you're looking at other types of equipment that have also used this method. That's important because we use equipment from many different industries. You might find, for example, different factors of safety on the equipment depending on which industry it came from, its intended use, or just depending on the manufacturer. So what you need to do is look at their documentation, or if you can't find the information, speak to the manufacturer directly. Obviously, there are lots of technical reasons why you'd use one piece of equipment over another, depending on the application. But using a ball-lock carabiner at the end of a lunge, because it's light and secure. In my work as a circus rigger, I'll often use the information about the equipment's minimum braking strength as a starting point to decide what equipment I'll use for a certain application. But it's only one aspect to that. Talk to your local circus rigger, Spend some time while you're at circus school learning about the equipment, how to use it safely. It'll expand on what you can do creatively and safely in the future. Check out the FED talk on dynamic forces to expand a bit on what I talked about in this video. Finally, thank you to SKH, Stockholm University of the Arts, and to FEDEC and all the people who contributed to the Erasmus Riggers project.